So message passing is a very nice primitive because it's fundamentally, you run a transaction on one chain that emits a message, and the actual mechanism for emitting this message will require some cross-chain interoperability protocol. So Wormhole is an example of a cross-chain protocol that supports message passing in a generic way, which means your application can emit a message with some arbitrary payload targeting another chain, and the Wormhole will then take care of taking that message and delivering it to the destination chain of your choice. So an example of a cross-chain message is, or an example of an application that uses cross-chain messaging is the Portal token bridge, which is built on top of Wormhole. And the Portal token bridge's messages are responsible for essentially describing token transfers that are to be interpreted in a cross-chain environment, which means on the source chain, you lock up some funds, emit a message, which then gets picked up on a target chain, and then the message will allow you to mint wrapped assets corresponding to the locked up assets on the source chain. So that's a very clean message passing model. And the benefits of message passing is it's agnostic. It's pretty agnostic to the runtime environments of your smart contracts. So if you think about concurrency control models of more traditional programming languages, where you, let's say TypeScript. In TypeScript, you have async await style concurrency, but the problem there is that it kind of assumes that you're operating in a sort of homogeneous computation environment where you can execute some action and then wait on the result in the same computation context. Message passing is more agnostic to what's actually happening on the receiver side. And in particular, that's very beneficial for cross-chain communication because different blockchains might have very, very different calling conventions as far as their smart contract entry points are concerned. Memory models, the whole ecosystems might be very different. And so communicate with message passing. A very important thing for a cross-chain application is that you carefully design the state machine of your user interactions. So if you have multiple components on multiple chains communicating with each other, let's say in a ping pong style fashion, where you're sending messages back and forth, you have to be really careful about designing the error cases of, what happens if you're sending a message through that maybe represents a token transfer to a recipient chain, but maybe the smart contract on the recipient chain has a revert condition in it that doesn't allow the user to unlock the funds. What do you do then? You need to handle that error case very carefully, and when you're going back, provide some mechanism for the user to be able to unlock the funds that they put in. If you don't think about these error cases, then users lose their funds, and it's going to lead to very bad user experiences.